Hi, Geometry. It is May 5th, and we're going to do an easy topic today. It's just one main topic. So your work grade for today is just taking these notes with me and resubmitting them, and then doing a quizzes practice. That's like 12 questions, I think, something like that, on exactly this concept. Okay, so here we go. All right, so today we are talking about circles in geometry again. That's our entire unit. But we're going to focus on two types of angles. One we've already talked about, and that's the central angle. Okay, so a central angle is an angle that's inside the circle, obviously, and that actually uses the center of the circle as its vertex. And then its rays go all the way out to the outside edge. Okay, and what we know about that central angle is that whatever this angle is at the center of the angle itself is going to be the same measure as the arc out here. So if we're going to name this angle, we would say that this is angle angle A, and that looks like a Q, B. And if they wanted me to find the measure of it, remember we would use an M in front for a number. So we'd say angle AQB is equal to 60. And then if they said find the measure of the intercepted arc, we would say that the measure of arc AB with the little arc symbol over it is equal to 60. Cool. That's the main idea that we're going to be working on for central angles. So that's a review piece. Now, we want to also remind you that if we used a 60 here, the entire way around the circle equals 360 degrees, right? Circles are 360 degrees. So if this part of the angle is 60, then this part around this way has to be 300 degrees, and the arc that goes around this way also has to be 300 degrees. Okay, so we also have the other angle that is the measure of angle. How would we say that one? We would say AQB, but going the other way. How would I say that? I don't even know how I would say that. Would be 300. So the measure of that arc, that one I can get to. I can get to the measure of the other arc by saying the measure of arc ACB, which would be going the other way, would be 300 degrees. Good? All right, so not only keep in mind that we're mostly focusing on the angle that they wrote in there, but there's also the other angles too that still work as well. Okay. All right, so working on to our next part then. Name all the central angles and find their measures. Okay, so in this one, we're going to focus on the three that are right there. We're not going to worry about the ones that are opposite, right, that go around the long way. We're going to worry about the main ones, okay? So let's talk about the one that is equal to 80 degrees. Okay, so the measure of angle, how do I get to 80 degrees? I'd have to go from R to S to Q. Angle R to S to Q, R to S to Q is 80 degrees, right? Okay, do we have another one that we can measure in here? Yeah, how about R to S to P is 140. Measure of angle R to S to P is 140. Is that it? Is that all the ones we have? No, we also have this remaining one over here that hasn't been marked yet, but we can go calculate it. So we know the measure of angle P to S to Q has to be whatever is left over to make up 360. So let's go do a little bit of math. If I add up 80 plus 140 together, I'm going to get 220 degrees. And we know that this angle has to be the remaining amount. So if I do 360 minus 220, I'm going to get 140 degrees as well for that one. Cool. So 280, 360, yep, that seems to work pretty well. All right, so we've got those angles. Now, not only do we have those angles, we also have their intercepted arcs. So this arc over here would also be considered a 140 degree arc. So I could say the measure of arc Q to P is going to be equal to 140. And working our way backwards, this arc right here, because its angle is 140, is also going to be a 140 arc. So the measure of R to P as an arc is also going to be 140. And then lastly, we have the measure of this one right here is also going to be an 80. So the measure of arc RQ is equal to 80. So remember with arcs that if you only use two letters, it is the shortest way on that circle between those 2 points. Okay, the part of the circumference that goes directly from R to Q, no stops, no going around the long way. If you want to go around the long way, you got to give me 3 letters so that I know that I have to go through that middle letter to get there. Okay. All right, so that was kind of review from last week, but we're still going to practice it this week. And then the other big concept we're going to work on today is inscribed angles. Okay, so we already did central angles. Today we're going to work on inscribed angles. So inscribed angles are going to be angles where the vertex is actually on the circle, not on the center, and that the rays go all the way through the circle to the other side. Okay, notice that the vertex of this one does not go through the center. Now, even Mrs. Power made a mistake earlier when she was assigning quizzes, and I might have misnamed the quizzes, is I called it an interior angle, which we have not gotten to yet. Okay, so an interior angle is one where the vertex of the angle is not on the circle and not on the center. And then an exterior one would be one that is outside the circle. So we're going to practice those later. Today we're just going to work on the ones where the vertex is either in the center or on the circle itself. Okay, so looking at our definition for this one, we have an inscribed angle is an angle in a circle where the vertex is on the circle and the rays of the angle form chords within the circle. Remember, chords were just line segments that go from one point on the circle to the other point on the circle. Okay, and we know something really special about these. So remember how in a central angle they match? In an inscribed angle, the angle itself is going to be half the amount of the central angle or of the intercepted arc. So let's show you what we mean by that. All right. So on this one, let's say that looks to me like I'm going to make it up. I'm going to call it a 100-degree central angle, right? So we could say that the central angle has a measure of the angle of POQ is going to be equal to 100 degrees, right? And we know that this amount right here, that the measure of the arc P to Q is also going to be equal to 100. Okay, but here's the really cool thing is if this is 100, hold on, let me go change the color over here. If this is 100 over here, it is still the same intercepted arc that's going to go all the way over here to vertex A and make an inscribed angle. So we can tell by looking at it that this angle is definitely bigger than this angle. And we know by the theorem that it's exactly half. So this would be a 50-degree. It would be half of 100. So the measure of angle PAQ is going to be 100 divided by 2, or you could say it is 1/2 times 100. Either one of those would get me 50 degrees. Okay, so the angle itself is not always going to match the arc. It depends on where that vertex is, tells us whether the numbers are going to be exactly the same or whether the arc is going to be bigger. And again, you should be able to tell by looking at it. If this is a 100-degree arc, right, the central angle is the one that matches. So if I go further away, it should be smaller. Okay. All right, so let's go practice that. And we're going to show you one special case as well. Okay, in example 3. Here we have a central angle. Okay, so we have the measure of angle, let's do COB. So if I start here and I go here and then I go there, that is a flat angle. So that means that that angle is going to be 180 degrees, right? So we know that the measure of the arc from A to B is also 180 degrees. This amount from here to here is 180 degrees. Okay, so if I have an inscribed angle that goes to the same endpoints to make that same arc, so that would be these two. They're going to end at C and B just like the arc did. Sorry, did I call that correctly? Nope, I did not. Let me go back and fix that. That is not that. It is AB. Okay. So now we have the measure of angle CAB is going to be 90 degrees, even though the arc is still, wow, what is wrong with me today? It is not AB, it is CB, right? The arc here is C to B. C to B. So the arc to C to B is 180. Let me go back and finish this one. So the arc from, this is a C, this is a B, this is an A point, right? So the arc is 180 both times, but the measure of the angle is different depending on whether it's going through the center or not, right? So even a straight line has an angle measure of 180 degrees. Now that's kind of cool, isn't it? Like if you think about that, we have this flat line that gives us 180 degrees, which makes sense. Halfway around the circle is a half of 360. And then half of that is the inscribed angle on the circle itself, is 90 degrees. Okay. All right. So just for fun, let's play with this one a little bit more. Let's say that I found out that this angle right here is 40 degrees. Okay. So I'm going to say, let's say that the measure of angle ACB is equal to 40 degrees. What could you tell me about its arc? Because remember, now it has a vertex that's on the circle, right? And if I follow its ray is going to go out to here. So I have just found this arc measurement. So the measurement of arc AB is going to be how much? Is it going to be 40, 20, or 80? Well, that depends on where the vertex is. Since it's on the circle, it's going to be smaller. So that means that arc AB is going to be twice as big. It's going to be 2 times 40. It's going to be equal to 80. Okay, so if this arc is 80, then that inscribed angle is half as much. All right, let's follow that to the last side, right? So if I follow that to the last side, what would you say the measure of angle ABC is over here? Okay, so the measure of this one, let's see how much is left in that triangle, right? We still know that triangles have to add up to equal 180, and we've already used up 90 and 40. So if I subtract 90 and I subtract 40, I'm going to get 50 left over. So I know that the angle is equal to 50 degrees. Well, then how much is its intercepted arc? So if I take this one and I follow it all the way out, the arc A to C is going to be equal to 25, 50, or 100. Which one? So if an angle is on the circle, the vertex of the angle is on the circle, right? This angle 50 is going to be half as much as its intercepted arc. So this would be 100. Now, how could I check that? Well, I could add up all the outside arcs and make sure they add up to 360. And I know that I did it right. Okay, so this is our main concept for today that we're going to work on is inscribed angles. In some of the titles, I accidentally call them interior angles. Inscribed angles, okay, are going to be half as much as their arc lengths. Okay, all right, so let's go practice a couple of these just to make sure. Okay, so in this one, they are asking us to go and find the measure of angle P. Okay, so the measure of angle P is going to be this angle right here. So I'm going to go and find, oh, they gave me the intercepted arc is 70, right? So what I know is the measure of arc MN is equal to 70. So the measure of angle P is going to be half as much. Why? Because angle P, the vertex is on the circle. It's not on the center. So it's going to be that half as much amount. So half of 70 is going to be 35 degrees. Good. Okay, so then this is a 35. All right, next one. Let's try this one over here, and it says find the measure of the arc from P to O. So for P to O, I'm going to use this angle right here to help me. So here I know that the measure of angle PNO is equal to, is that 58 or 56? Let's go see. That is a 56. So then the measure of the arc P to O is going to be how much? Is it going to be 56, more than 56, or less than 56? Angles are half as much as their arcs when they're on the circle and not at the center. So then this would be 56 times 2, which is 112 degrees. Cool. All right, so we get the main idea for these. All right, and that is it for us for today. So one of your points is just to copy down these notes and send them on back to me. The other part is to go do that quizzes, and the rest of the week is yours. Maybe take a look at some of the stuff that you're missing, and let's start working on catching up on some past assignments if you can. If you need any help with anything, let me know. Have a good week, you guys. Hey, it's Mother's Day this weekend, so maybe think about something nice you could do, a nice letter, a nice activity for this weekend. All right, we'll talk to you later, guys.